Hello and welcome to another video on Pythagoras' theorem. Now in the last video we looked at applying Pythagoras' theorem to calculate the hypotenuse in a right angle triangle. Now in this video we're going to work backwards, so we'll be given the hypotenuse and we need to calculate one of the shorter lengths. So I'm going to go through an example to begin with. So we've got this right angle triangle here. We've been given the hypotenuse, which is 10. We don't know what the units are, but for our purposes that doesn't really matter. And we've been given one of the shorter lengths, and we need to calculate this length over here. So let's just remind ourselves what Pythagoras' theorem states. So with any right angle triangle, if we square each of the shorter side lengths and then add those two values together, that will give us our hypotenuse squared. So with this particular example, if we were to square this side length and then square this side length down here and then add these two values together, that will give us our hypotenuse squared. So we can see that we don't know what this value is, so we can't square it. We do know what this value is, so the side length at the bottom here is 8. So if we square this, that gives us 64. And we know the hypotenuse, so the hypotenuse squared is 100. So we know that this box here plus this box gives us this box. So to work out what's in this box, well, we can just go backwards. So we can just do 100 subtract 64, and that gives us 36. So we know that this side length squared is 36. So to work out what this side length is, we can just take the square root of 36, and that gives us 6. So we're just applying Pythagoras, but we're doing it in reverse. So this is the process if you think about it visually, but let's go through the formula. So the formula for Pythagoras' theorem is a squared plus b squared is equal to c squared, and a, b and c just represent the three different side lengths. A and b are always the shorter side lengths. The order doesn't matter, so let's just call this one a, this one b, and c is always the hypotenuse. So notice with our example, we already know what the hypotenuse is. We need to work out a. So we need to get a on its own. So first of all, let's get rid of this b squared. So if we subtract b squared from both sides, we'll be left with a squared is equal to c squared minus b squared. And then to get a on its own, at the moment we're squaring, so we need to square root both sides. So we'll be left with a is equal to the square root of c squared minus b squared. Now if we think about this in terms of our example, hopefully we still get the same answer of 6. So what we're trying to work out, a, well, that is going to be equal to the square root of c squared. Well, c is 10, so it's going to be 10 squared minus 8 squared. Now 10 squared, well, that's 100. And we're going to subtract 8 squared, which is 64. And now 100 minus 64, that's 36. So a is going to be the square root of 36, which is 6. Now everyone has different preferences as to how they like to think about it. You may like to think about it algebraically like this, or if you prefer doing it visually like this, then that's great also as well. So I'm going to give you a few questions for you to have a go at now. Okay, I've got 5 questions for you to have a go at, so pause the video and see if you can answer these questions. Okay, let's go through these together now. So the first one, well, these 3 questions here, for each right angle triangle below, work out x. So you can see that we've got the hypotenuse, which is 13 centimeters, and we've got one of the shorter side lengths. We need to calculate the other shorter side length. So we know that if we square this value here, and then square this value here, so square the 2 shorter side lengths, add them together, that will give us our hypotenuse squared. So what is 12 squared? Well, that is 144. 13 squared is 169. So if we add these together and it gives us this, well, to work out what's in this box, we need to subtract. So 169 minus 144, that gives us 25. But be really careful, this side length isn't 25, it's this side length squared is 25. So to work out what the side length is, this value, we just need to take the square root of 25. So the square root of 25, and that gives us 5. So our answer is 5 centimeters. Looking at the next one, so If we square 9 squared, well, that is 81. And if we square this value here, we don't know that, so we can't do that at the moment. But when we add these together, that gives us this value squared. And 15 squared, I can do that in my head, that's 225. So I might need a calculator, but I think I can do this in my head as well. 225 minus 81, that is 144. 144, and that's nice because this is a square number. So the square root of 144 is 12. So our answer is 12 centimeters. Okay, and the last one, I think I might need a calculator for this. So again, let's square both of our side lengths. So 24 squared, I will need a calculator for that. 24 squared is 576. 576. And 25 squared is 625. 625. So because this is the hypotenuse, and the reason you can tell it's the hypotenuse is because it's always opposite the right angle. So we're going to take 625, subtract 576, and that gives us 49. So this length squared is 49. So to work out what this length is, we just take the square root of 49, which is 7 centimeters. Okay, let's look at the next question. Chantel has completed this question. Can you spot any mistakes? So she's completed it algebraically. So she's written out A, B and C for her 3 side lengths and written down the formula a squared plus b squared equals c squared. So that's all fine. Now she's substituted in her values. So for A, she's put in 5, which is correct. For B, she's written in x, which is correct. That's the one that she doesn't know and she's trying to work out. And then for C, she's written in 13. So that's all fine to begin with. Now, 5 squared. 5 squared, this is where she's gone wrong because 5 squared does not equal 10. She's done 5 times 2. She should have done 5 times 5. So that should be 25. And also, if we look over here, she's done 13 times 2 to get 26. She hasn't squared it. So 13 squared is 169. So that's where she's gone wrong. Instead of squaring, she's multiplied by 2. So I'm not going to go any further here because she's going to get the wrong answer because this is wrong. Okay, moving on to the last one. Victor has completed this question. Can you spot any mistakes? So he's completed it algebraically again, just like Chantel did. And he's written out the formula, a squared plus b squared equals c squared. But then looking at his diagram, he's labelled the sides incorrectly. Because remember, C is always the hypotenuse. So you can see here that his hypotenuse, he's labelled up as B, which is over here. That should be C. According to his formula, C is the hypotenuse. So he's just got B and C the wrong way round. But it's quite a big mistake because everything else following on from that is going to be wrong. So these two values should be switched round. So that's going to be it for this video. Hopefully that was useful. And I would say that the most common mistake that people make with applying Pythagoras' theorem is that they forget to look at which side length corresponds to the hypotenuse. So they'll blindly just square the two numbers and add them together and then take the square root. Whereas if you've got the hypotenuse and you want to work out one of the shorter side lengths, then you have to subtract instead of add. So just be really careful with that. I'm going to do one more video on this topic, and that's going to involve lots of different problem-solving style questions involving applying Pythagoras' theorem. So hopefully you'll join me for that video, and thanks again for watching. Take care.